So today we're going to look at various recurrence relations. We start out with a few definitions. Our first definition is a recurrence relation is said to be homogeneous in case every term has an A in it. Now, what I mean by term, every recurrence relation is a sum of things and each part in the sum is a term. So homogeneous means every term has an A in it. It's linear if each term has at most one A in it. It's constant coefficient if every coefficient of the A terms are just numbers or constants. It's of order K if the smallest index in the recurrence relation is, and I'm going to make a little change, n minus k. Okay, so if the smallest index is n minus k, then k is largest. All right, now let's look at a few examples. My first recurrence relation looks like this. A sub n is a sub n minus 1 plus 5 times a sub n minus 2. I look at that. Every term has an A in it. Here's my first term. Here's my second term. Therefore, it's homogeneous. Every term has at most one A in it. This only has a sub n minus 1. This only has a sub n minus 2. Therefore, it's linear. The coefficient in this A term, you don't see it, so I'm free to put in 1. 1 times anything is that thing back. So this has coefficient 1. This has coefficient 5. 1 and 5 are both numbers. That's what makes it constant coefficient. To figure out what the order is, I look at the smallest index. The smallest index is n minus 2, and that makes it order 2. My next example is a sub n is a sub n minus 1 times a sub n minus 2. So when I look at that, it is homogeneous. Why? Because every term has an A in it. I have only one term, and that term consists of a sub n minus 1 times a sub n minus 2. So it is homogeneous. You will notice it is not linear because to be linear, each term has at most one A in it, but this term has two A's. It is constant coefficient because the coefficient of this term, which you don't see there, we can assume to be 1. It is of order 2. Why? Because again, the smallest index is n minus 2. My next example is a sub n is n times a sub n minus 1 plus 6 times a sub n minus 3. If I look at that, it's homogeneous. Why? Each term has only one A in it. It's linear. Why? Each term, this one and this one, has at most one A in it. It's of order 3 because that index is n minus 3. That's the smallest one in the recurrence relation. Notice it is not constant coefficient. Why? Because the coefficient of this term here is n, and n is not a number. It changes. Our next example, a sub n is a sub n minus 2 plus 6 times a sub n minus 4. Plus, and then I have this other term, n plus 2. All right. This one is not homogeneous. Why? Because here's this term, n plus 2. It doesn't have an A in it. And every homogeneous recurrence relation has to have an A in it. It is linear. Why? Because each term, there's one term, there's one term, there's one term. Each term has at most one A in it. Now the last term has no A's, but that's at most one. It's constant coefficient. Why? Because the coefficient of the a's, again, here, the coefficient of this term is 1, coefficient of this term is 6. It is of order 4. Why? Because the smallest index is n minus 4. Finally, I look at the example. A sub n is n times a sub n minus 1 plus 6 times a sub n minus 2 plus 5. I look at that. It's not homogeneous. Why? Because it has this 5. It is linear. Why? Because every term has at most one a in it. This has no a's in it, but that works. It is not constant coefficient, again, because the coefficient of this term is n, and n is not a number. It is order 2 because the smallest index is n minus 2. All right, so that's what homogeneous, linear, constant coefficient, and order k means. These definitions, in fact, are not in the book, so that's why I put them in here. In the next video, we're going to look at trying to solve a special recurrence relation that fits all of those definitions. So we're going to try to solve linear, homogeneous, constant coefficient recurrence relations of order 2. So that's all I want to talk about in this video. Have a good day. Bye.